The Boxer is a modular 8x8 armored fighting vehicle engineered around a two-part architecture that separates a protected drive module from swappable mission modules. This split design is the defining technical feature. The drive module houses the engine, transmission, fuel, driver station, and vehicle control systems inside a welded, high-hardness steel armored hull, while the mission module is a self-contained, armored payload capsule that bolts to the top with a precision interface, power and data couplings, and multi-point structural fasteners. In practice, a unit can remove one mission module and install another using a field crane in a short maintenance window, turning the same chassis from an APC into an IFV, ambulance, command post, engineer carrier, repair/recovery vehicle, motor carrier, cargo variant, or training platform without deep rework of the base vehicle. Because the crew and dismounts live entirely within the mission module, upgrades or repairs can be made off-vehicle, depot side, while the chassis stays in service, and new roles can be introduced across a fleet with minimal disruption. The program's roots go back to 1999, when the ARTEC Consortium, short for Armored Technology, was formed to develop a new 8x8 to meet German and British requirements. In the UK the effort was labeled Multi-Role Armored Vehicle, MAV, and in Germany it carried the GTK designation, Gepanzertes Transportkraftfahrzeug. France withdrew its early participation and the Netherlands joined later. The vehicle ultimately received the name Boxer. The UK left the industrial grouping due to budget priorities at the time, while Germany and the Netherlands carried the project forward to production. ARTEC GmbH today is a joint venture of Krauss-Maffei Wegmann, Rheinmetall Radfahrzeug, and Rheinmetall Nederland, following Rheinmetall's acquisition of Stork PWV, with final assembly lines in Germany and the Netherlands to ensure manufacturing flexibility and surge capacity. A first large combined order in December 2006 covered 472 vehicles in 9 qualified variants for German and Dutch forces, and the first series Boxer was fielded in 2009 after a development program that accumulated roughly 180,000 kilometers across 12 prototypes configured in 9 versions to validate the automotive package, protection, and logistics concept under the demanding qualifications of both armies. The drive module's mobility system is centered on the MTU V8 199TE21 turbodiesel rated at about 720 horsepower, 530 kilowatts, coupled to a heavy-duty ZF automatic transmission, a 2-speed transfer case, and permanent 8x8 drive with selectable differential locks. With combat weight around 36,500 kilograms in representative configurations, the platform delivers a specific power of approximately 21.8 horsepower per ton, sustaining road speeds up to about 103 kilometers per hour and road ranges on the order of 1,050 kilometers with mission-ready loads. Independent suspension at each wheel station, paired with telescopic hydraulic dampers, high-capacity hubs, and run-flat tires under a central tire inflation system, keeps the long wheelbase compliant on broken terrain and allows tire pressures to be trimmed for sand, mud, and cross-country travel. The steering geometry acts on the first and second axles to curb turning radius on a hull that measures roughly 7,930 mm in length and 2,990 mm in width, with a baseline roof height near 2,370 mm and a generous 500 mm ground clearance to preserve underbody standoff. Off-road performance parameters include a 60% gradient, 30% side slope, and 0.8 m vertical step, a 2.0 m trench, and an 0.8 m fording depth without preparation, giving the Boxer track-like mobility off-road and highway efficiency on-road. Strategic mobility was baked in. The chassis and mission module can be separated for shipping efficiency, and the platform is compatible with road, rail, sea, and a 400m air transport when configured for weight and envelope limits. Dimensions and internal layout reflect a strong human factors emphasis. The driver is seated forward left in the drive module behind wide-angle periscopes and, when specified, fused day/thermal driver vision enhancers for night or dust. The power pack sits forward right behind armored service doors and top deck access panels designed for rapid line replaceable unit swaps. The mission module occupies roughly the rear two-thirds of the vehicle and is structurally independent, arriving with its own floor, wiring looms, HVAC, and stowage architecture. A full-width rear ramp with an inset emergency door provides primary egress for dismounts, while roof hatches forward and aft offer emergency exits and support a standing sentry behind a remote weapon station if doctrine requires. In the APC configuration, the module seats 8 infantry on blast-attenuating mountings in addition to the 3 vehicle crew, rails, tie-downs, and EMI-conscious lighting and power outlets are arranged for tactical radios, personal electronics, and soldier system charging. Protection is organized around a layered scheme that starts with an all-welded ballistic steel hull and scales through add-on packages. External applique uses amAP, Advanced Modular Armor Protection, composite/ceramic suites to raise ballistic thresholds across arcs and the roof against armor-piercing small and medium-caliber threats and fragments. Underbody survivability leverages the natural standoff created by the drive module/mission module split and a multi-layer floor architecture to channel and dissipate mine and IED energy. The vehicle has been qualified to STANAG 4569 Mine Protection Level IIIb in representative fits, and energy-absorbing seats for both crew and dismounts limit transmitted accelerations. Automatic fire detection and suppression cover the engine bay and inhabited volumes, while an overpressure/filtration NBC system keeps the interior habitable in contaminated environments. Signature reduction measures, exhaust routing, muffling, IR-suppressing shrouds, angular external geometry, and attention to external clutter, cut acoustic, infrared, and radar returns to complicate detection and targeting. For active survivability, laser warning receivers cue multi-barrel smoke/obscurant launchers, and the platform provides electrical and physical interfaces for soft and hard-kill active protection systems where users specify them. Electronic architecture and networking were designed to make the Boxer born digital. A standardized power distribution and high-speed data backbone supports battle management systems, friend or foe interrogators, Blue Force trackers, and software-defined radios without bespoke rewiring for each national fit. German IDZ, Infanterist or Zukunft, soldier system interfaces have been integrated on APC modules so each soldier can update navigation and tactical information and recharge personal devices, while Dutch vehicles incorporate contemporary C4I frameworks for modern networked operations. The open interfaces create headroom for counter-UAS payloads, electronic attack/jamming kits, tethered quadcopters, meteorological sensors, and muzzle velocity radars. High-capacity alternators and smart power management enable silent watch modes that sustain sensors without idling the engine. Breakaway connectors between the drive and mission modules isolate damage, and embedded health and usage monitoring instruments aid predictive maintenance and fleet management. Industrialization focused on reliability, logistics, and life cycle cost from the outset. The development fleet's roughly 180,000 kilometers of trials fed durability improvements into series production, and the production representative vehicles achieved high availability in early fielding. Broad use of proven COTS/MOS components, most visibly contributions from MTU for the engine, ZF for transmission, BEAR for thermal management, and Rankine driveline elements, reduces spares complexity and eases sustainment. Multiple final assembly lines at Krauss-Maffei Wegmann and Rheinmetall in Germany and at Rheinmetall Netherlands create capacity and redundancy, while the commonality of hubs, brakes, control software, and diagnostic tooling across variants compresses training pipelines and parts holdings. The power pack is a line-replaceable unit that can be extracted through the front deck with minimal disconnects. The cooling group uses high surface area radiators and controlled speed fans tuned for hot, high, and dusty environments, with reversible flow cleaning options to keep cores clear. The Boxer's armament and sensor suite scale with roll. At the light end, APC and command variants mount stabilized remote weapon stations for 7.62 by 51 mm machine guns, 12.7 by 99 mm heavy machine guns, or 40 by 53 mm automatic grenade launchers such as the Heckler & Koch GMG, all paired with day/night sights, laser rangefinders, and digital ballistic solvers integrated on the vehicle bus. For the IFV role, several manned and unmanned turrets are fielded. A common solution is Rheinmetall's Lance modular turret with a 30 by 173 mm dual-feed cannon, airburst ammunition programming, a coaxial 7.62 mm machine gun, and provisions for pod ATGMs such as Spike LR. Hunter-killer architecture is standard in these turrets: a commander's independent panoramic sight, a gunner's thermal channel, and stabilized drives allow rapid target acquisition and engagement on the move, while fire control logic handles lead, superelevation, and ammo selection. Ammunition stowage is compartmented and often placed in armored bins below the turret ring with blow-off paths, and safety interlocks prevent interference between turret sweep and the rear ramp. Modularity translates directly into variant breadth. The Boxer APC is the primary troop carrier configuration, effectively a mothership for infantry with robust communications and soldier system integration so that dismounts step off with current situational data. The protected medical evacuation vehicle uses a higher roof module and flexible interior layouts to carry 2 to 4 litter casualties plus seated medics, matching the mobility and protection of combat variants so it can follow closely in high-threat zones and protect both patients and crew. The Boxer Cargo/C is a protected resupply variant designed to move more than 2 tons of stores under armor directly to forward elements. An innovative handling system simplifies palletized load transfer, and the bay can be rearranged for mission-specific cargoes during peace support or humanitarian operations. The Cargo/C2 derivative adds a command and control fit to the cargo module and is used for staff tasks at the tactical echelon while preserving protected lift capacity, a configuration adopted in Dutch orders. Command post vehicles form another major branch. German FUFs and Dutch CPV configurations host secured voice and data networks, multi-screen workstations, server/radio racks, and sometimes a large-format 40-inch display at the rear to support briefings and improve shared situational awareness for troops outside the vehicle. Interiors are designed for reconfiguration between on the move and at the halt modes with adaptable seating and cable management, and electromagnetic compatibility has been engineered from the outset to support dense radio suites. Engineer group carriers, fielded for example by the Netherlands as Boxer AEG, transport a squad of combat engineers with their personal kit and dedicated stowage for explosives, charges, and breaching tools under armor. These modules can act independently for route clearance or provide a protected workspace during reduction and demining tasks, with the core mobility and protection of the family. Repair and recovery support has an in-family solution in the Boxer BDR, which carries a crew of 4, driver, commander, gunner, and technician, together with tools, consumables, test equipment, and diagnostics to execute field repairs and battle damage assessments under armor, sustaining availability at the point of need. To build and keep driver proficiency without risking operational vehicles, the Boxer DTV driver training variant mirrors the APC's weight and dynamic behavior but replaces the rear module with a dedicated instructor compartment. Redundant controls allow the instructor to override gear selection, throttle, and brakes. An optional duplicate steering system further improves safety. An active passenger protection function is built in for rollover events, and the compartment's large glazed areas are complemented by mirrors and camera systems to give the instructor precise awareness around the vehicle. Climate control upgrades support training in high-temperature environments, and the digital control unit in the cabin manages auxiliaries like wipers, windshield heating, and seat warmers for all-weather training realism. Automotive and survivability fundamentals enable the variants to share the same demanding mobility envelope. A torsionally rigid chassis with generous reserve and hub, suspension arm, and roof ring strength accommodates heavy turrets, armor growth kits, and new electronics without re-engineering core automotive elements. The growth margin is central to the Boxer value proposition. Even after installing a modern IFV turret and a full tactical communications suite, the vehicle retains track-like cross-country mobility and highway pace. That same reserve supports heavier payloads such as remote-controlled howitzer modules, short-range air defense fits with radar masts and missile canisters, and counter-UAS arrays with elevated sensors and high electrical demand, all while preserving human factors quality inside the module so fatigue does not erode mission effectiveness. From an operational viewpoint, the Boxer was conceived to handle the spectrum of modern land operations described in the three-block war concept: high-intensity combat, stabilization/peace support, and humanitarian tasks in complex, rapidly changing threat environments. The modular mission module approach gives commanders a composable toolset. APCs carry infantry sections to the line of departure and pull them out under fire. IFVs bring medium-caliber effects and precision ATGM overwatch. Command posts sustain network tempo. Engineer carriers open routes. Medical modules pull casualties without breaking the advance. Cargo variants keep ammunition and water flowing under armor, and repair modules preserve momentum. The ability to swap missions at the fleet level, reallocating modules across drive modules as tasking changes, expands the utility of each chassis and compresses the logistics footprint. Network-centric interfaces ensure the Boxer participates fully in modern C3I architectures, and the digital backbone allows national radios and battle management systems to be spliced in without bespoke rewiring. Hard numbers round out the technical picture. In representative APC fits, the Boxer carries a crew of 3 with 8 dismounts. The combat weight sits around 36.5 tons with the corresponding 21.8 horsepower per ton specific power from the 720 horsepower MTU V8 199 TE21. The platform measures roughly 7,930 mm long by 2,990 mm wide by 2,370 mm high, rides on a 2,580 mm track with 500 mm ground clearance, and achieves a top speed just over 100 km per hour with a notional road range exceeding 1,000 km. Obstacle negotiation includes the already noted 60% gradient, 2.0 m trench, and 0.8 m step. Standard fording is 0.8 m without kit. Baseline ballistic protection is up-armored with amAP composite packages. Mine protection is validated to STANAG 4569 Level IIIb in relevant builds, and typical light armament fits include a 7.62 mm or 12.7 mm machine gun or a 40 mm automatic grenade launcher on a stabilized RWS. While IFV solutions add a 30 by 173 mm cannon with programmable airburst and optional ATGMs. The suspension is fully independent with torsion characteristics and telescopic hydraulic shock absorbers at each wheel station, and all steering gear is positioned above the wheel centers in protected housings to avoid damage in rough terrain. Behind these figures is a certification and logistics philosophy that treats survivability as more than armor thickness. The protected capsule concept provides residual mobility after attack so crews can self-extract, wiring and fluid runs are routed to minimize sympathetic damage, and the vehicle's HUMS data is exploited to schedule maintenance and pre-position spares. Fire safety, SPAL control, and post-hit egress drills were qualified during formal trials so armies could write realistic TTPs for crews. Compliance with NATO standards for fuels, lubricants, connectors, and data buses avoids vendor lock-in and smooths multinational operations. The end result is a platform that entered service with high operational readiness, benefited from the broad adoption of proven subsystems by suppliers like MTU, ZF, Bayer, and Renk, and retained strong growth potential as new sensors, effectors, and electronic warfare payloads crowd the modern battlefield. Taken together, the Boxer's technical proposition is straightforward and compelling. It offers a high-protection hull with genuine growth headroom, a powerful, reliable automotive package that keeps pace with tracked formations on roads and maintains high cross-country mobility, and, above all, a mission module ecosystem that decouples payload innovation from chassis procurement. In a market crowded with competent 8x8s, that last point is the advantage most difficult for competitors to replicate at scale. As threats and missions evolve, commanders can roll a chassis into a workshop, unbolt yesterday's mission module, and bolt on tomorrow's capability without disturbing the core vehicle, delivering a protected, networked, and adaptable combat system whose engineering depth has been proven from prototype miles through series production and into operational service.